So that means here, what you can do is to say that sine of, using this, sine of 5 pi over 4 equal to sine of 2 times 5 pi over 8. But this is equal to 2 times sine of 5 pi over 8 times cosine of 5 pi over 8. And then from this equation, you can, because we know that, what is sine of 5 pi over 4? So first of all, here, what I'm using is this. I'm using this equation, sine of 2 theta is equal to 2 times sine theta times cosine theta. I'm using this equation. Okay. But what is sine of 5 pi over 4? And I know that sine of 5 pi over 4 is sine of 5 pi over 4 is equal to sine of pi plus pi over 4, which is minus root 2 over 2. And also cosine of 5 pi over 4 is cosine of 5 plus pi over 4. So you can plug it here and you have this equation, minus root 2 over 2 is 2 times sine of 5 pi over 8 times cosine of 5 pi over 8. So you can use this equation to find sine of 5 pi over 8. I will do it in a second, but there is an easier way. It's easier to compute cosine of 5 pi over 8 first. And I will tell you why. Here, the bottom line is, you can use this equation to find sine of 5 pi over 8. And remember that whenever you have cosine, in general, cosine theta is the square root of 1 minus sine squared, right? Let me finish this and I will tell you another way. Let me finish this first. So is this clear so far, what I did? Is this equation on the top clear for everyone? Liana, is it clear? Okay, now if you square this, square it. So on the left side, you get 1 over 2. And on the right side, you get 2 times sine square of 5 pi over 8 times cosine square of 5 pi over 8. So 1/2 is 2 times sine square of 5 pi over 8. Cosine square is just 1 minus sine square. So 1/2 is 2 times sine square of 5 pi over 8. So let sine of 5 pi over 8 be equal to t. Then you have 1/2 is equal to Or let's say sine square is equal to t. Let's say sine square, because you have sine square and sine to the power 4. So let's say that sine square of 5 pi over 8 is t. So you have 1/2 is equal to 2. So you have 1/2 is equal to 2 times t minus t square. Then from this equation, you can, this is a quadratic in t, and you can find t, right? So that means, what is the quadratic equation that we have here? So you have 2t squared minus 2t plus 1/2 equal to 0. So you can solve this equation for t. And once you have t, you can find sine square of 5 pi over 8. The only thing that you have to be careful about is you have to know whether sine of 5 pi over 8 is positive or negative. What do you think? Sine of 5 pi over 8, is it positive or negative? Five pi over 8 is located in the second quadrant, right? 5 pi over 8 is located in the second quadrant. So sine of 5 pi over 8 is positive. Bless you. So you find t, and then you sub it to the equation for sine, and then you're done. So that is one way. Maybe we can find easier way. Any suggestion for another way to compute sine of 5 pi over 8? I mean, of course, without calculator. If you use calculator, then
Can you draw it?
yeah, you can, but how you want to compute it? 5 pi over 8 is in the second quadrant. Or you can convert. I mean, you have to use radians. I will show you. I will show you. Don't worry about calculator. Let's try another way. So remember that what we want to compute sine of 5 pi over 8. But if I can compute cosine of 5 pi over 8, then I'm done, right? Because once you have cosine, then sine is easy. So let's try to compute cosine of 5 pi over 8. Again, remember that cosine of 5 pi over 4 is equal to cosine of 2 times 5 pi over 8. So now what is cosine of 5 pi over 4? Cosine of 5 pi over 4 is minus, what is cosine of 5 pi over 4? Cosine of 5 pi over 4 is minus root 2 over 2. And this is equal to, but we also know that cosine of 2 theta is equal to cosine 2 times cos square theta minus 1. So we know this equation. So that means cosine of 2 times 5 pi over 8 is 2 times cos square of 5 pi over 8 minus 1. Therefore, 2 times cos square of 5 pi over 8 is 1 minus root 2 over 2. right? Cosine of 2 theta is 2 times cosine square theta minus 1. Is this clear? Yes. Yes, some of the formulas. Okay, now from here you can compute cosine square of 5/8, right? Cosine square. And we know that sine square of 5/8 is just 1 minus cos square. Now, what is sine square of 5/8? 1 minus cos square. So you have cos square. What is 1 minus this? Right? And then that is sine square. So sine, the only thing, again, recall that sine of 5/8 is positive. So because there are two solutions, it could be negative or positive. Sine, you have sine square equal to this. So that means it's either positive square root or negative square root. But we know that 5/8 is in the second quadrant. So its sign is positive. Beautiful question. Thank you, Ganges. That was a nice question.
Is it Alex?
Why the cosine?
He pointed, yes.
Why the cosine? Why the cosine square just becomes the sine square? And the last two and last three is there.
The second last line. So sine square is 1 minus cosine square.
Yeah, but why no?
Well, we have cosine square, right?
Yeah.
This is cosine square. You just subtract it from 1. You get 1 plus. Oh, by the way, this is, I missed something. Here you have root 2/2, right? My mistake. Because this is 1 minus root 2/2. No.
Okay, maybe I'll test something so.
Who knows? Now, can you compute? This is a similar question. Can you compute cosine of pi/12 and sine of pi/12? I mean, without calculator. Any suggestion? I mean, this is easier, but anyway, it's good to, yes. That's one way. That's a good answer, but that is more complicated. There is an easier way to do this. Yeah, that's something that's similar to what I did here. Okay, exactly. That's something similar to what I did here. But let's think about this. Can you write pi over 12 as a sum or difference of two well-known angles? So can you write pi over 12 as like A plus or minus B? Two angles. Means the subtraction difference, I tell you. So as you said, something that you suggest is pi over 12 is pi over 6 plus pi over 6. Oh, no, sorry. That's pi over 12 plus pi over 12 is pi over 6. Never mind. But there is another way. How about pi over 3 minus pi over 4? Does it make sense? Pi over 3 minus pi over 4. Because what is 1 over 3 minus 1 over 4? One over 3 minus 1 over 4. What is it? 1 over 3 minus. 1 over 3 is bigger than 1 over 4. It should be positive. What is 1 over 3 minus 1 over 4? 1 over 12. That's it. Okay, so pi over 12 is just pi over 3 minus pi over 4. So that means cosine of pi over 12 is cosine of pi over 3 minus pi over 4. Now you have the formula for cosine of a minus b. So cosine of pi over 3 minus pi over 4 is just cosine of pi over 3 times cosine of pi over 4 plus sine of pi over 3 times sine of pi over 4. So this would be equal to 1/2 times root 2 over 2 plus root 3 over 2. So this is equal to root 2 plus root 6 over 4. Does it make sense? Yeah, that's if in the test, that's fine. But if you want, you can convert it to decimals using your calculator. Okay. Now let's go back to the questions. Wait a moment. Is question 2 easy? I mean, can you do question 2? I think I discussed 2b yesterday. What is 195 degrees? In terms of radians, do we know? Do you know what is 195 in terms of radians? (195) is 180 plus 15, right? That's right. Now, can you compute? So here is 195. Actually, that's a good one because it's related to pi over 12, right? That's a very good one. So 195 degrees is 180 plus 50. That is equivalent to pi plus pi over 12, right? Radians. So that means cosine of 195 is equal to cosine of pi plus pi over 12. Now, what is cosine of pi plus pi over 12? It's equal to minus cosine of pi over 12, right? But I know here, I just computed cosine of pi over 12, actually. So this is exactly minus this value, negative of this value. I mean, for sine, you have to do the same thing. Sine of 100 is equal to sine of pi plus pi over 12. But this is equal to minus, again, sine of pi over 12. Why it's minus sine? Because it's in the third quadrant. In the third quadrant, both cosine and sine are negatives. But you have to compute sine of pi over 12. How to compute sine of pi over 12? You do the same trick. Pi over 12 is pi over 3 minus pi over 4, right? So sine of pi over 12 is sine of pi over 3 minus pi over 4. So this is equal to sine of pi over 3 cosine of pi over 4 minus sine of pi over 4 cosine of pi over 3. Is that clear? Okay, now let's go to the, what is 165? Yeah. So can you compute the 50 degrees is pi over no. Yeah, pi over 12, right? Yeah, pi over 12, right? So you do the same thing. So you can do question 6. 165 is 180 minus 15. So it's pi minus pi over 12, right? So 165 degrees equivalent to pi minus pi over 12. What about 105? You can say it's pi half plus pi over 12. Because 90 plus 15 is just 105, right? Good. So next page. Any question? Look at that. There's a goose. Okay, next page. You can open the door, invite him. Maybe he wants to learn advanced functions. Go to university. Okay. Any question on this page? On the nth day of the year, the number of hours of daylight at the city in Canada is given. Okay, so this is just a number of hours of daylight in terms of the day. N is the nth day, right? So part A, how many hours of daylight should be on the 200? So you just plug in n equal to 200 into this equation. So you have 200 minus 76 divided by 365 times 2 pi. And then you compute sine. Just use your calculator. Yeah, so let me write it here. Can you read the question for me? So the formula, what is H? H is what is it? 4.303 times. Okay. N minus. That's it. Plus. That's me, wait. Divide. No, I think that's plus. plus 11.3. So the first part is clear, right? So part A, if n equal to 200, then h would be just compute it, right? Just plug it in and then compute. Now for part B, what is part B? What is part B? What is part B? The question. Can you read completely?
On what days of the year should there be 9 hours of daylight?
Okay, so that means for part E, you want to find n so that h equal to 9, right? So that means you have to solve this equation. 9 equal to 4.03 sine of 2 pi times n minus 76. So that means sine of 2 pi times n minus 76 divided by 365 equals to 9 minus 11.43 divided by 4.0. So now what is sine inverse of this? So can you tell me, use your calculator to compute sine inverse of this guy? So that means 2 pi times n minus 76. So you got, it's easier if you can convert it to pi so that we can simplify. It's convert it in radians. So let's see. Degree. Did you got in terms of radians? By the way, you have to be careful when you compute sine inverse in your computation, it should be in terms of radians. So what is sine inverse of this in terms of radians? What you got, Liana? Hmm? 38 radians. First of all, this is a negative number, right? -0.6, negative 0.6, exactly. So this is equal to negative 0. Let's say 0.65 radians, right? That's it. So that means 2 pi times n minus 76 divided by 365 is minus 0.65. Oh my God. Sorry. What happened? Oh, yeah. Okay. So there are two solutions. One is minus 0.65. So that means basically two pi times n minus 76 over 365 is equal to 2k pi minus 0.65, or you have another solution, 2 pi times n minus 76 divided by 365 is equal to 2k pi plus pi plus 0.65. Okay.
I would have the 2k pi.
Hmm?
I would have the 2k pi.
Because, so for example, when you say sine of some theta is equal to 1/2, just simple thing. Sine of theta is 1/2. What are the possible thetas? So the possible values of thetas are like pi over 6, 2 pi plus pi over 6, 4 pi plus pi over 6. There are infinitely many of them, right? For any integer k. And then you can simplify and write everything in terms of n, right? So that means for the first, let me work on the first solution. Let's just simplify the first solution. So let's just simplify the first solution. So it is, you have n minus 76 equals to 365 over 2 pi times 2k pi minus 0.65. So n equal to 365 divided by 2 pi times 2k pi minus 0.65 plus 7. So, and then in order to find exact value of n, you let k equal to 1, 2, 3, 4. And for each one, you have to compute n. So for example, if k is equal to 1, then you have 365 over 2 pi. And of course, also 0. I forgot that. K can also be 0. So you begin from 0, 1, 2, 3. So you plug 0, and then for k equal to 0, you have n equal to 365 over 2 pi times minus 0.65 plus 76, and so on. Okay? Do you know how to compute n for each of them? You just plug in into the formula for k, and then you can find n. Yeah. Yeah. Now, can you tell me, use your calculator, because it's also important how to use calculator efficiently and properly. So can you give me the first 3 answers for n? So I mean the solutions for k equal to 0, 1, and 2. So for radians, so first of all, you can choose between degree and radians. Is there any degree? I think it's here. So degree radians, so let's say 2. What happened? Oh, here it's radians already. You see? If you choose this, say 1, 2, 3. Let's say 1. It's very confusing. Okay. So this should be degree.
Choose from the mode.
No. Degree. Oh, here is degree. This letter, it means it's in degree. But if you again do it, let's say 2, now you're in radians. Now whatever you do is in radians. But if you want to use pi, this is just pi.
So you do shift and then that thing?
Yeah.
Okay, got it.
Okay, so for example, let's compute cosine of pi over 3. 1/2. Now, can you tell me what is n for the first 3 values of k? K equal to 0, 1, and 2. Maggie. Okay. Yeah.
So like K, if he was 2, then it would be 400.
Okay.
Would it make sense? So it's only K equals 1 makes sense.
Okay, that's right. How about k equal to 0?
Oh, sorry, K equals 0, 38, yeah.
So k equal to 0, n is, you said, 38?
38.
And k equal to 1, n would be 103? 400? Okay. Yeah, so this you passed the year. I mean, this answer is true, but if you want to think in terms of years, days of in a year, so you go to the second year. 403. What is 365 plus 38? It's 403, right? So the answer makes sense why you get 403. So it repeats, which is, I mean, in terms of the days, 403 is the same day as 38. Let me ask you this question. Imagine that now what day is today? Today is Wednesday, right? August 16th. Can you tell me what day is next year? I mean, what weekday is the next year, same date, August 16 next year? Today is Wednesday. What day is next year, August 16? It's a cycle, right? Let me pause here and explain. This is just something. Okay, now let's go back to the questions. Please return this by tomorrow, okay? Yeah, all of these questions. Do you have any other questions? Nothing?
For the principal angle, it's just like, on the first page, it's asking for the principal angle and the reference angle, aren't they the same thing?
Let's look. Which page?
First page, chapter 5.
First page, chapter 5.
Question 5.
Question 5.
Yeah, it's asking for the principal angle and the reference angle, aren't they the same thing?
Oh, no. Here the reference angle means, well, let me show you in this picture. I mean, it's not a big, deep thing. Just when it says principal angle means basically, for example, you have 240 degrees. That's the principal angle. So that's the smallest positive angle, right? But the reference angle means the angle between this ray and the x-axis.
Yeah, I knew that. I was just confused on the principal angle.
So-
the research should give you a different-
So this is it. So here, this one is the reference angle. This red one, do you see? This is the reference. So for example, what is the reference angle?
60.
240 minus 180 is 60, right? That is just some terminology. Okay,
I
So-
don't think I have the view.
Maggie, do you have question?
Give up 2A for
2A? Okay, very good question. So can you read the whole thing, please?
2 cos A sine squared A
Mhm.
cos squared A minus cos A minus
-2. That's it. So I would start from the right-hand side. So the right-hand side is 1 minus 2 cos A minus sine square A. And remember that 1 minus sine square is just cos square, right? So you have this equal to cos square minus 2 cos A divided by cos square minus cos A minus 2. So you can write it, factor it as what? Alex, tell me. Cos A minus 2 times plus 1. So this would be equal to cosine A times cosine A minus 2 divided by cosine A plus 1 times, oh sorry, so far so good, clear? And then you just cancel out cosine A minus 2, so you get cosine A over cosine A plus 1. So and if you divide the numerator and denominator by cosine, you get 1 over 1 plus secant. Or you can say you can factor at the denominator is cosine A times 1 plus secant. And then you cancel out cosine. Okay. Clear? Any other questions?
more versus
First question. So it says that verify for x equal to pi over 6. So that means let x equal to pi over 6, and let's see, is this equation true or not? So when x equal to pi over 6, then what is sine x? 1/2 cos x is root 3/2. And then what else we have? Secant x is 2 over root 3, right? Then on the left-hand side, you have 1 plus 1/2 divided by root 3/2 plus root 3/2 divided by 1 plus 1/2. So let's compute this. So you have 3 over 2 divided by root 3 over 2 plus root 3 over 2 divided by 3 over 2, right? Now the first is 3 over root 3. The second is root 3 over 3. Is that right? 3 over root 3 plus root 3 over 3. So what you get here? So this would be equal to 9 plus 3 is 12 divided by 3 root 3, which is equal to 4 divided by root 3, and it's exactly 2 times secant x, right? It's just a computation. So this 4 over root 3 is just 2 times secant x, because secant x is 2 over root 3. So you just verify this identity for x equal to pi over 6. So verify using a graphing calculator. I mean, here, most of calculator don't have graphing, but you can graph in your, I mean, you can neglect this, but it's fun to see the graphs of these two functions. So for example, you go to some websites like Wolfram Alpha, and then you can graph the two sides of this equation. Just plot it using your computer. Some of the websites do it online, okay? And then for part C, you have to prove it algebraically. Do you want me to do part C? Can you do it yourself?
So I need like make pi over 6 to 8.
Oh, only for part A?
I mean,
For C, no, for C, you have to prove it in general for any x. That's just for any x, you have to prove this identity. And you can begin from the left-hand side. Okay? Can you do it, all of you? Okay. So it's better to begin from the left-hand side and then simplify. Just let me tell you some simple questions. So if someone asks you what is the period of f of x is
Which question is this?
so what is the period of each of these? I just made it up. What is the period of each of these functions? What is the period of the first one? 2. So for the first one, t equal to 2 pi over pi, which is 2. How about the second one? Is 2 pi over 4, which is pi half. Third one 2 pi over 2, which is equal to pi. Now, can you tell me what is the range of each function? What is the range of the first one? So the maximum would be, yes, minimum 2, -2. So the range is minus the interval -2 to 8. The second one, the maximum is 4, minimum -2. And the last one, that's right, and negative. Let me, this is a bonus question I want to give you. And just give me a second. So this is called, for your information, this is called, I guess, Heron's formula. So proof, this is a bonus question. Proof. Okay. What is the Heron's formula? Heron's formula say that if you have a triangle with base AB, with the sides ABC, it says that the area A is equal to square root of S times S minus A times S minus B times S minus C, where S is just A plus B plus C. To prove that the area can be given, can be computed by this formula. So S is A plus B plus C. This is a very nice formula for the area. So it just gives you the area of a triangle with 3 sides. You don't need to find the altitude. Okay, prove this.
This is the bonus on the test or just?
General bonus for your assignment. I can give you some help, but I want you to start doing some. I mean, you can find the height, the altitude in terms of ABC. And so. Okay. Okay, guys, so I'm here. If you have any questions, you can discuss it. So we finish this unit, and then tomorrow I'm going to begin a new unit. If we had time, I can also teach you a little bit about complex numbers. Some extra things.